Rational numbers. That's what we're going to learn about today. First, a definition. A rational number is a number that can be expressed in the form A over B, where A and B are both integers and B does not equal 0. And remember, you might have heard the rule that you can't divide by 0. That's why B cannot equal 0. And just to give you a visual of what we're talking about here, and I'll go back to this last slide a little bit. You've been learning about a lot of different families of numbers. The first of which was the natural number. Okay, those were your counting numbers, 1, 2, 3, 4, and so on. And I'm going to create a Venn diagram of this. So I'll just make a little circle. But all natural numbers also fit inside another grouping of whole numbers. And you remember what that is. Whole numbers are all of the numbers that are the counting numbers, 1, 2, 3, 4, and so on, and the number 0. Okay? And then beyond that, we had our integers, which is represented by the letter Z. I don't know why it's the letter Z. I think it has something to do with the word in French. But that not only includes 0, 1, 2, 3, 4, and so on, but it also has the negative numbers, -1, -2, -3, and so on in that direction. And now finally, we have all of those which fit into the family of rational numbers, which are denoted by the letter Q. And that one I do know the answer for. We use the letter Q because that's the first letter of the word quotient. Do you remember what a quotient is? That's the answer to a division problem. And all fractions, I say this all the time, really are division problems. That's what every fraction is. So this is a nice little visual of the different types of numbers that we've encountered so far, that you've encountered so far. So let's go ahead and do some conversions. We're going to convert each of the following to a decimal. So 3/4. We want to change it into a decimal. So we're going to do the number 3 divided by 4. Okay, we can't actually put 4 into the number 3, so we are going to need to put the decimal point there. 4 goes into 30 7 times. 7 times 4 is 28. Subtract, and you get 2. Introduce another 0 and bring it down. 4 goes into 20 5 times. Exactly. So 3/4 is the same as 0.75. And let's do this other one, 24/36, or 24/36. The first thing I'd like to do actually is to reduce the fraction, because I don't know if you noticed that the number 6 goes into both of them. 6 times 4 is 24. And 6 times 6 is 36. And just off of that, I can see that we can go a little bit further and bring them down by 2. So what we're really looking for is the number 2/3 as a decimal. So let's go ahead and divide 2 by 3. Just like the prior example, we're going to need to introduce a decimal point. 3 goes into 20. How many times? 8. Is it 8? No. 3 times 6 is 18. That's why I was thinking 8. Okay? And 20 minus 18 is 2. Bring down the 0, we have another 20. Well, that means it's going to be another 6, which is going to give us another 20. And another 6, which is going to give us another 20. What we're going to write down is 0.6, and I'm going to actually go ahead and just put a little bar over that, which indicates it's 0.6 repeating. That's the exact amount. Since the instruction says to round to the nearest hundredth, we could say that that approximately equals, and that's what an approximately equal sign looks like too. It's an equal sign that's a little wavy. 0.67 is approximately what we're looking at there. All right, how about a few more fractions into decimals? We'll do 2/9. We're going to do the number 2 divided by 9. Well, we can't put 9 into 2, but we can put it into 20. It goes in twice. But look at that. The same thing happened. We got 2, which we bring down would be 20. So it's just going to be a string of 2s. We can say 0.2 repeating, which approximately equals, since the problem asks us to round, to 0.22. And then our last one on this page is a mixed fraction. So for the time being, we can actually just ignore that 2 and do 4 divided by 5, or 40 divided by 5. Goes into it 8 times, which is 40. So we have 0.8. And is that the answer? Well, no, there's that 2 that we got rid of originally. So 2 4/5 is the same as 2.8. All right, that's converting some fractions into decimals. And how about going the other way now, though? Writing the following decimals as fractions in their simplest form. Well, 0.125 is the same as 125 out of 1,000. How did I know it was 1,000? Because 3 places after the decimal is the thousandths place. Okay, good. So let's go ahead and just divide this. I know right off the bat that 25 goes into 125. Because 125, I memorized for other purposes, is 5 cubed. So I know 25 goes into it. 25 goes into 125 5 times. 25 goes into 1,000 40 times. Oh, and 5 goes into 40 8 times. 0.125 is 1/8. All right, and let's take a look at this next one. I'm going to ignore the 1 in front of the decimal for now, just like I did on our last fraction to decimal issue. We have 0.38, which is 38 out of 100. Both of these numbers are divisible by 2. 38 divided by 2 is 19, and 100 divided by 2 is 50. 19 is a prime number, can't make that any smaller, but we do need to reintroduce that 1. So what we end up with is 1 and 19/50. And if we need it to be an improper fraction, we could convert it, but there's no need to do that right now. And finally, let's do 2 more. We have 0.042. That's the number 42 out of 1,000. Well, both of those numbers are even, so they're both divisible by 2. 42 divided by 2 is 21. 1,000 divided by 2 is 500. 21 is 3 times 7, which there's no 3 or 7 in 500, so that's as small as we can get it. And then finally, we have 2.56. That's 56 out of 100 with a 2 in front of it. But we can reduce that. I would say that the number 4 goes into both of them. 4 goes into 56 14 times. And 4 goes into 25. 4 goes into 100 25 times. So as a mixed fraction, we get 2 and 14 out of 25. But let's say, just for the sake of argument, that we needed it to be an improper fraction. Remember how that's done. You multiply the denominator times the number in front. 2 times 25 is 50. And then you add it to the numerator, which becomes 64 over 25. And that's that same number as an improper fraction, all of which are rational numbers. And that concludes our lesson on rational numbers.